here. So there are two peaks that within the search sphere that is significant in this case. And then if you take a look at the first value at the peak level, this is the P for FWE corrected. I know the screen resolution is not so good, but at your screen it should be much clearer. So here you are still doing familiarized error correction, but only restricting within the sphere. So, and then you see the p-value. So one is 0.01, which is really nice, and then the other one is 0.05, which is marginal. Perhaps you could still use that, but at least you have like one peak. So you could report this and then use it for replication. So now this is like one way to circumvent. If for whole range level you could not do family-wise error correction, then you could instead use a region of interest approach. And then, so you would have several different ROIs, several different region of interest. So for each of the region of interest, you should test it separately. Okay. Normally, for like, if you have bilateral region of interest, left and right, at least personally, I would test separately, left and right, to see if there's any, like maybe there's only like activations on one side but not the other side. So you keep your options, or you keep your the possibility to search for a specific activation at like one side of the brain.
Actually we have in the PD is 0.1. So the just like what we report psychological studies. So just report this T is 3.65.
Yeah. So
and since we have this kind of small correction, so we have to also at the same time report this.
Yeah. So because we need to correct for multiple comparison, the uncorrected p-value is not very useful. We won't report it if we are doing small volume correction. We will ignore them. The t-value would be useful because we would still want to let people know what exactly, or the size of the effect it is. So the t-value, definitely you would report it, and then you would report the FWE corrected p-values. Okay. So and then you could make reference to the literature, because there are nowadays many people doing this approach. So they will do small volume correction with a priori region of interest, and sometimes people also report uncorrected data after they examine the a priori region of interest with small volume correction as some kind of exploratory analysis. So, yeah. Well, this is like only the threshold, or the threshold for data exploration. So it is relatively more liberal as compared to the threshold here. So we just don't want to screen out any potential activations before we go straight to take a look at the small volume, to take a look at a priori region of interest. So you should not use a too high threshold for data exploration in this case. Otherwise, you won't be able to see whether there might be something important, or you will miss something. Okay, so this is combining like one sample t-test with data exploration or data interpretation. We still haven't covered the two sample t-tests. Well, two sample t-tests perhaps we don't need to do it because it's highly similar to the one sample t-test. So if you have two groups of subjects, let's say one control group and then the other clinical group, you ask them to perform some kind of functional task, you define the contrast at the first level, you simply bring the contrast images to the second level. So you are comparing the two groups. So it's not that difficult. But I want to quickly show you what you could do with what we call the flexible factorial design before we finish. Okay. Alright, so here, let's say, now I could choose design. Okay, let's try. Okay, so what you need to do, so now we are, I just want to quickly demonstrate the flexible factorial design. If it's too quick and you couldn't fully grasp the idea, don't worry, I have like some reference that you could read. So because I don't think I have enough time to go into every single detail, because it's relatively more complicated and also very flexible in a sense. So that's why it's complicated, because there are so many scenarios you could use. The gist for using a flexible factorial design as compared to one sample t-test or two sample t-test is that you keep using the original beta images instead of defining a contrast in the first level and bring it to the second level. By doing so you are looking at each individual subject's corresponding beta image, put it to the second level, and you could divide the expected variance with respect to the different conditions. For example, for the same subject, let's say you have two different betas. So one beta, let's say we model the one back task and the two back tasks separately. So there's only one section, so there's only one beta for the one back task, and then there's only one beta for the two back conditions. Okay? So we are going to contrast one back versus two back again. It's the same. And so there are two beta images per subject. So one corresponding to the one back condition, the other one corresponding to the two back condition. And then we bring it to the flexible factorial design. We could model individual differences in this group. So we could specify a subject factor, which is between subject factor. Then we could have another factor for the working memory, which has two levels. Okay? So you could have like a one back condition and a two back condition. But then this factor is within subject. So you could specify how you are going to divide the variance. So you could define this factor of working memory as within subject variance, whereas for the subject factor is between subject variance. So you could kind of like cut the tofu, you know, divide your variance accordingly, according to the condition you are looking at. You could also have some assumptions about the equivariance. Let me see. Yeah, you could also specify the assumption of the variance are equal or not. So let's say if you have a clinical sample versus a healthy sample, for the clinical subjects, if they are more like heterogeneous, then you should expect their performance would not have equal variance across, within the group. So in this case, you could define the equivariance assumption to uphold or not. So that's why here you have, for each factor you define into the flexible factorial design, you have two things to think about. First of all, whether the observation is independent for this factor or not. If it is a within subject factor, then you say no, it's not. They are not independent. If it is a factor concerning individual differences, then they are kind of like independent. Okay. So this is first thing, and then you could define, or you could assume whether the variance observed in this factor is equal or not. So that's why it is like a more sophisticated way of defining how you divide your explained variance with respect to each different factor. So that's why, in theory, using the flexible factorial design will give you more sensitivity, a little bit more sensitivity compared to the old, like you define your contrast, or you simply use your beta and then put it to a second level one sample t-test. So that's what we call the improvement in this case. So well, I think there's no exact limitation, but then you need to think about whether you want to keep a parsimonious model versus a more complicated model, but that explains everything. So you need to like balance out whether you overfit your data or not. Yeah. So I mean, just quickly try to go through it once, but I think we don't have the chance to really run a model. So anyway, you just need to define a name of the factor. So every time you click on here, flexible factorial design, you could add some more factors. So normally we will have the subject factor and as well as the experimental factor. So let's say we have we give a name for working memory. I just quickly use the soft form, and let's say because it is within subject factor, so the observations are not independent from each other, right? So we choose no, they are not independent. And then supposedly the performance for the one back condition and the two back condition should have equal variance, right? Because they are performed by the same subject. Unless the two factors are really like have huge differences, then you should expect they have unequal variance. But normally they should have equal variance if it is like a within subject factor, right? You assume the subject is performing consistently. And then the other two you don't need to worry about. No, it's not defined here. You simply define your factor first. You just need to define whether the factor is independent or not, and then you define the variance is equal or not. Okay? And for the second factor, then it's subject. I just say subject, and it is an independent factor because for each subject you have individual variations. Okay? And depending on the group composition. For example, if you are working with a group of healthy adult university students, you have no reason to expect that they are performing so differently. So in this case, I would say that okay, we should also expect equal variance, right? Unless you have a really heterogeneous group. And again, the Gramian scaling and cover, you don't need to worry too much about this, because you would read from the information or supplements below that this option is for PET or BBM data. Okay? And the gist is here, so you need to specify your subject, and then you specify your scans, and then you specify your data, your conditions. So you need to, let's say, we only have, let's say we only have one subject, because it's easier. Then you need to choose the respective scans. For example, if you only have like two conditions, as I said, one beta for the one back and then one beta for the two back, then you choose simply two images. Sometimes we have like a factorial design, we have like a 2x2 design, so altogether we have 4 images. So you need to choose the respective 4 different images here. And then you need to define the conditions. So you need to build a matrix to assign the respective condition of the images according to the sequence of the entrance. For example, if I'm entering the one back image or one back beta first, and then the two back beta. So you need to keep in mind. And let's take this as an example. So you have two images. The first image belongs to the one back condition, and then the second image belongs to the two back condition. And let's say we have 2 subjects or 10 subjects, and in this case you need to make reference to the order of factors you have before. So the first factor, if you remember, is about the working memory, and in the respective column you should code the image. So the first column is like, so I'm putting this 1, 1, 2, 1. So which means that for each row here, for the matrix, for each row represent the image you put in. And for the column, which means that the factor it corresponds to. So the first column corresponds to the working memory load, the second column corresponds to the subject factor. So here I'm putting 1, 1, 2, 1, which means that the first image, the first beta corresponding to the one back task and subject 1. And then the second image corresponds to the two back condition and subject 1. Okay? So I don't put any scans here, I just want to demonstrate. So let's say if I have a second subject, so you choose the scans in the conditions. Now you put 1, 2, 2, 2, because the two images, the two betas, is corresponding to the first image is the one back for the second subject, and then the second image is the two back for the second subject. So it will become clearer if I add the first subject. Okay. So now, again, I assume that I put the scan for the one back and the two back images, and then I will say 1, 3, 2, 3. Because the first scan, the hypothetical scan we are putting in is the one back condition for the third subject, and then the second image would be the two back condition of the third subject. So and so on. So clear? I just want to demonstrate how you could define this. Let's say, okay, 1, 4, 2, 4. So remember, if you add one more factor, then you need to add one more column in your conditions. Okay? So now for the fourth subject, because the second column belongs to the subject factor, and then the first column belongs to the working memory factor. So the first image you put in should be the one back of the fourth subject, and then the second image would be the two back of the fourth subject, so and so on. And so let's imagine that you've put in all this, and then you have the option to choose what effect you want to examine in your model. So let's say you could have a main effect. Let's say if I'm only interested in the main effect of working memory, I don't really want to take a look at the subject main effect. And also I'm not interested in if there's any working memory changes according to the subject, which means the interaction. So I could simply choose one main effect, and you need to put in the factor number. So here we have two factors. So the first factor is the working memory factor, the second factor is the subject factor. always, I mean, we tend to ignore the subject factor. At least we are not interested in looking at it. So we will simply put 1 as the main event, and then that's it. So this is the simplest flexible factorial model you could build, which will somehow work in the same manner as you define the contrast in the first level and then bring the contrast image to the second level for a one sample t-test. I mean, this is a very quick demonstration. It doesn't necessarily mean that you could do that now, because I mean, I just quickly go through, so maybe you would forget, and then there will be confusion about I mean, what you are going to set, especially concerning the conditions matrix. I mean, it could be very confusing. But I mean, at least I want to introduce this to you so that you know, whenever you read something about the people using flexible factorial design, you know that they are trying to, I mean, use a more sensitive way to look at the data, at least. And then, I mean, when you really got some data, then, I mean, feel free to write to me. I mean, we'll see how we could we could do it, or maybe we could do another workshop. Yeah. So yeah, that's what I want to show you for the practical session. Yeah. Okay. So we still have a little bit of time. This is like in the plan that if you have any questions concerning maybe a study you want to like implement, or if you have, even if you have some slight ideas about maybe an fMRI study, then I mean we could discuss. We could have like a platform, a forum to discuss about what kind of things you need to think about, what kind of things you need to pay attention to, or maybe even if you have simply some ideas and then you want to check if it's feasible to study it using fMRI or not. I mean, yeah, we could discuss right now.
I have a question for the scans, the input of the scans.
Yep.
So is it the raw image of the scan of each subject?
Not the raw, but the results from the first level analysis.
Oh, okay.
So it should be the beta image or the contrast image.
Okay.
So for example, we have the contrast image. I mean, usually we don't do a contrast image, because if you do a contrast already, you are, I mean, asking some questions there. I mean, we normally, with a flexible factorial design, we use a regressor-specific beta, or regressor-related beta. So, which is like one, if you have a factor with 2 levels, then you have 2 betas. So for each level of the factor, you have one corresponding regressor, right? So for each regressor, you have a beta value or beta image. So you use that beta as an input. And basically, if you set up a flexible factorial design, it would be something like in the first level model, when you specify a contrast to compare 2 different conditions, it will be the same. So you would have a model with 2 different conditions at the group level. So one corresponding to the 1 vectors, the other condition corresponding to the 2 vectors, and then you need to set up a contrast. For example, 1 minus 1 or minus 1, 1 to compare 2 back versus 1 back. So then you are like saving the contrast equation to the second level instead of setting it up already in the first level and bring the contrast value to the second level. So it's like a matter of sequence of doing things, whether you do it at the first level or you do it at the second level. Questions, discussions, comments? Yeah.
I try to ask you to consult to extend an idea.
Mm-hmm.
So one idea is that it's about pictures. So
Mm-hmm.
since I'm interested in metaphors, so some of the pictures
Mm-hmm.
So though it's one picture, but it's not a normal picture.
Yeah.
So like a computer on the desk. This is a normal picture. It's something that we see. However, for instance, this that I discussed with Dr. Yu, if we put Earth in an ice cream, what is called the corn, ice cream corn,
Yeah.
then actually you know that the Earth cannot be put into an ice cream corn. So you may know this is a metaphorical expression saying that the Earth is melting. Okay. So this is one picture. Actually, since not many people know much, not many research have done in this field. So maybe I can also maybe first thing I research is visual cortex and see whether there are some differences in actually what you are talking about, the multivariate pattern analysis today is interesting to me because they already differentiate the pictures. Although they are pictures, but they are able to differentiate. So my question is that if I want to know whether how picture process this visual metaphor pictures differently from ordinary pictures. Maybe I put also an ice cream there as a contrast. So in that case, so shall I actually use multivariate pattern analysis?
No, I would not recommend that.
Okay, then starting, then how can I do my just like you use the general linear model to see whether there are some differences in this within subject design.
I would. Well, first of all, I think it ties to the experimental paradigm you're going to use. First of all, or maybe I will ask how you're going to instruct your subjects. You don't need to answer me, but I mean these are some points you need to think about. Because if you are interested in like metaphorical processing, then you need to somehow instruct your subjects to trigger this kind of processes. So maybe you need to let them know that it is not a normal picture, but it carries some kind of metaphorical meaning. You need to try to process it in order to bring out this kind of mental processing. Because if you are only taking like some images and then for people to see without telling them these are metaphorical, I'm not so sure whether it will be the kind of cognitive process you want to examine. So this is like you need to think about. So that's one thing. The other thing would be you would need, or it is recommended to that you have some kind of behavioral outcome to justify that what you're looking at is something exactly you want to see. No matter it is like reaction time measurement or some kind of subjective ratings or even more passive things like eye tracking, you name it. You need to have some kind of measurement to show that the task is doing or differentiating between the control pictures versus the metaphorical pictures. That's one important thing. Because if you don't see any behavioral outcome differences between the baseline versus the condition of interest, then it's very difficult for you to justify the kind of brain activities is really related to the differences between the two different conditions. So that's the second thing. So you need to test a paradigm extensively to make sure that it works, is doing what you want to do. There are behavioral outcomes that shows some differences, or at least that shows the subjects are doing what you are asking them to do. Then you could think about moving this paradigm to fMRI, and then you need to worry about the design of your paradigm. For example, whether you have a very efficient design or not, whether you are able to tease apart different conditions, think about the both response, the latency of both response, whether you are going to use a block design versus an event-related design. I mean, these are the basic questions you need to think about. Then it's closely tied to data collection, which sequence you use, and after data collection, then you need to analyze your data. I mean, I would definitely not recommend you to now think about like pattern analysis, because that would be a sudden jump. I would say, first of all, try to master the most basic ideas or the most basic concept for setting up an fMRI analysis. Make yourself familiarized with all the procedures, all the subtle things about experimental design, about scanning, about data analysis. Then perhaps the next step, once you get really familiarized yourself with all this, then you think about maybe some kind of multi-voxel pattern analysis. Yeah, otherwise you will be getting nowhere. Definitely. Yeah.
We will still have some time for an open discussions, but before we further open up our forum, let's give a big round of applause. And also then we have a small souvenir.
Thank you.
We'll be around for 10-15 minutes, so if you have any questions, please.
Yeah, you could just come to me individually.